Our first talk is Jerry Anunrojwong from Colombia. The title of the talk is Information Design for Congested Social Services, Optimal Need-Based Persuasion. And he's going to be telling us about how careful release of information about waiting times can improve access to social services. So Jerry, I'll let you take it away.
Hello, everyone. I am Jerry Anunrojwong, an incoming PhD student at Columbia Business School. And I'm here to talk about my work, Information Design for Congested Social Services, joined with Krishnamurthy Iyer and Vahideh Manshadi. The motivation for our work is that most social services are severely congested, leading to long waiting times and inefficiency. For example, there is a long wait list for public housing for low-income families, as well as long wait time for healthcare and emergency services. The reason behind this severe congestion is that these services are supposed to be inclusive, but they have limited capacity. Users have heterogeneous needs for the service. For example, in the right figure, you can see there is a wide distribution of income for people in the New York City public housing system. Some have extremely low income and really need affordable housing, while others are middle class, and this housing is a nice to have. But because the service is inclusive, they all use the service. The two main tools that we use to manage congestion, pricing and admission control, cannot be used in settings like these. Pricing can't be used for fairness concerns. These services are supposed to be inclusive and accessible to even low-income people. This is how the government's affordable housing program is different from the commercial housing market. Admission control can't be used for implementation reasons. It means you know the needs of everyone and is able to force anyone to join or leave the service. This is not practical. It's difficult to know how needy these people are. You can't force people to use the service when they don't want to, and most of the time you don't know enough about their backgrounds to disqualify them. Despite all these issues, social services are necessary, so the congestion has to be managed. Given this user heterogeneity, the natural question is whether we can share wait time information in such a way that users with lesser needs are incentivized to forego or delay using the service and thereby reduce congestion. This issue is relevant in practice. For example, an urgent care center in Ontario has this dashboard that provides wait time information, and the dashboard is, quote, especially useful for patients with less serious conditions who can use it to choose when and where to seek care. So the motivation is, can we use information design to manage conditions in these social service settings so that we can better target these services to those who really need it and improve welfare outcomes? Because we are talking about social services, the welfare metric should be fair in some sense. We don't want to improve the welfare of one group of users at the expense of another. Instead, we want to improve the welfare of all groups at once. That is, our criteria is Pareto dominance. Specifically, in this talk, we analyze information design in a stylized queuing model, serving users with heterogeneous needs. We compare the welfare outcome under information design against the simple benchmarks of full information and no information, as well as centralized admission policies, where the service provider can dictate who gets to use the service and know everything there is to know. The main takeaway of this paper is that with sufficient heterogeneity in need, information design can be powerful in improving overall welfare outcomes. Now, we will formally define the model. The service provider is in the form of an unobservable first-come, first-served single server queue. We assume that there are two types of users. The high-need users must join the queue and use the service. They have no outside options. The low-need users can choose to join or leave the queue. We make minimal assumptions on the user's utility, only that the utility function is decreasing and convex. We assume that low-need users are Bayesians. They form expectations about the unobserved queue length and decide whether to join or leave the queue. The high-need users always join. The service provider's goal is to use information design or signaling to share information about queue length to improve welfare. We define the welfare of each type in a standard way. With two types of welfare, we can define Pareto dominance. A signaling mechanism Pareto dominates another if the welfare of both types are higher, and it is Pareto dominant if no other mechanism Pareto dominates it. Now we look at our main results, comparing signaling mechanisms with simple benchmarks. The benchmarks we compare to are full information, no information, and first best or admission control. First, we compare with full info and no info. Before we go to the main result, we first look at the negative result when there is no heterogeneity. Only type L users. In this case, full info is almost as good as signaling, and both are better than no info. So signaling doesn't help much relative to full info. Now we reintroduce heterogeneity in needs, and signaling becomes useful in this more realistic setting. We can show that if type L and type H users are fairly balanced, then signaling Pareto dominates both full info and no info. Taking these two theorems together, we conclude that information design is Pareto improving if the population's need is heterogeneous. Now we compare with first best. We first define the weighted welfare to put weight theta on the low type and 1 minus theta on the high type. The corresponding optimal admission policy is AP theta and signaling mechanism SM theta. We can prove that there is a theta bar such that for theta lower than this, the signaling mechanism is independent of theta. And for theta higher than this, the signaling mechanism achieves first best. This means that for some regimes, the signaling mechanism achieves first best. This is very powerful because the first best is an ideal benchmark when you know everyone's type and can force anyone to join or leave. In practice, you can't know or do these things, but we can still implement the first best welfare with signaling. This also means that incentives of the service provider align with both user types, and information design plays a purely coordinating role. Now, we look at some numerics to make our comparison with full info, no info, and first best clearer. We plot the high type welfare on the x-axis and low type welfare on the y-axis. The full info and no info are 2 points, purple points here. Full info, no info. You see, under full info, the low need people don't internalize their externalities on the high need people, so the high need welfare is really low. Now we plot the Pareto frontier of the signaling mechanism in blue. These are all the possible dominant signaling mechanisms. We can see, just as our theorem suggests, that there is a signaling mechanism that Pareto dominates both full info and no info. Now we plot the Pareto frontier of the admission policy in pink. We see that many signaling mechanisms achieve first best. There is a wide overlap between the frontiers of the signaling mechanism and the admission policy. To conclude, information design provides Pareto improvement in welfare over no info and full info if there is sufficient heterogeneity in needs. Moreover, under some regimes, information design can coordinate users' actions to achieve the first best, that is, to get the same welfare outcomes as centralized admissions policies. The high-level takeaway of all these is, when common levers are unavailable, signaling is still useful. We consider more extensions in the full paper, including user abandonment and more heterogeneity of types of needs between two types. You can see the full paper in archive here, and thank you for listening.